You're listening to Don't Waste Water.
They started with the push to electric vehicles, but you don't have electric vehicles without batteries. You don't have lithium batteries without lithium. You don't have lithium without mining. So you need to start up that whole supply chain.
Hello, bonjour, and welcome to the Don't Waste Water podcast.
To process 1 ton of spodumene, you need 1.5 gigajoule of natural gas, 1 gigajoule of electricity, 24 tons of water, and half a ton of sulfuric acid and sodium ash.
I'm your host, Antoine Valter, and in today's episode, I'm pleased to welcome Tony Strobbe as my guest.
If you have a DLE plant, it's a hot soup. Basically, it's very abrasive for the piping. It's very abrasive for all the materials you use.
Tony is EV Supply Chain Projects Director.
The PowerPoint presentations, and I say that to everybody who wants to listen to me, the PowerPoint presentations are written to entice investors to invest. It wouldn't surprise me of the gigafactories, if we talk about gigafactories right now, 50% of the gigafactories, the capacity won't be there.
Every Monday, he compiles a dedicated content piece he shares on LinkedIn that covers one aspect of that said supply chain. So if you like what he shares today, make sure to follow him. I hope you haven't missed last week's conversation with Ben Sparrow from Saltworks. If you have, shame on you, but let me bring you up to speed. We're diving into the lithium value chain to discuss, evaluate, and uncover the opportunities for water technologies and professionals in this rapidly growing application that taps into several layers of the water industry. Now, when you visit a foreign country, it's often a smart move to start by getting the basics of language and culture. So that's the mission I tasked Tony with today. Let us break down the fundamentals of lithium processes. Why, where, and how do we refine lithium? What do we need to know on the technical side of the equation, but also on the geopolitical aspect of things? Where does the lithium value chain sit in the greater scheme of the EV supply chain? Those are just some of the questions we'll get to answer today. And that will give us valuable keys to leverage the next nuggets in this series, such as the company that shall build the first ever commercial scale direct lithium extraction project, or the dedicated team within the world's largest water company that's conceived some of the most emblematic lithium refining projects. Before kicking off, let me just share with you that I'm back from the Global Water Summit in Berlin and the Blue Tech Forum in Edinburgh. It was a great experience to get to meet many of you and to discuss water, wastewater, water entrepreneurship, and much more. I'm so grateful for the many heartwarming feedbacks you gave me on the podcast. It means the world to me. And beyond just an ego boost, it's critically important for me as I strive to produce you the most useful content every week. If it's the case, I'm glad it is, and you can help me out by sharing the pod with your friends, colleagues, boss, or team. Yet, if you feel there's something I shall be doing differently or better, hey, feedback doesn't have to be positive. Come share me your thoughts on LinkedIn or by mail, antoine@dww.show. I also came back from both Berlin and Edinburgh with great pieces of content. I spoke with the GWI team and the Blue Tech team. I also cut some quite insightful interviews with Xylem, Veolia, Aquatech, Kemira, Evoqua, Ginkgo Bioworks, and more. I can't wait to share you all of this once I've digested and edited it, but enough for that sidetrack and all that teasing. I'll leave the floor to Tony, and I'll meet you on the other side.
You're listening to Don't Waste Water, the podcast that helps water professionals to improve their wastewater treatment, optimize their operation costs, and keep up with the latest market trends. This podcast is brought to you by GF Piping Systems. As a leading supplier of piping systems made of plastics and metal, GF Piping Systems is the global expert for the safe and reliable transportation of water, chemicals, and gas. For more information, visit gfps.com.
Hi, Tony. Welcome to the show.
Hello, how are you?
Well, excited. I'm really excited about the conversation we're about to have for many reasons, because I think you're filling a void within my series on the lithium word, value chain, whatever you want to call it, but also because I'm usually opening this show with a postcard, and you're sending a postcard from Mexico, and I really don't know anything. I never was to Mexico. So what can you tell me about Mexico that I would ignore by now?
Well, Mexico, like you say, it's a beautiful country. I like being here, that's for sure. It's also an exciting country because it's not like Europe where the companies are already settled. It's basically still evolving, let's say. Certainly in the lithium industry, but I'm sure we'll talk about it later.
Well, actually, if I can be curious to start with, if I'm right, you're from Belgium. So how do you end up in Mexico?
Ooh, long story. But basically, if you look at my story, since I was young, I was very interested in the world around me. When I was 10, for instance, I remember spending my Sunday mornings at my grandma's house. And basically, right across the street, there was an industrial laundry. I really liked to go in there and look at the machinery. The machinery were turning around in hot steam, very noisy. The machines were running without interference of people. I would say that's also where it started, my interest in machinery and productions. And basically, when I was 15, I had to choose my education. It was 1984, long time ago, I know. But that was also when the computers came up. So that was a technology that was really new. I know for some of your readers, they will not understand that a world without computers is actually possible. But that was my youth without computers. But that the first year the computers came around is also the first year that actually computer technology classes were introduced. So I went to follow computer technology. And after my computer technology, I went further and go in my engineering degree, where I studied electrical and mechanical engineering. Now, directly after my studies, I was able to join the firm where I did my thesis. And basically for my thesis, I had to develop a machine that actually tested tires under a specific load, forklift tires. And when I started working, they asked me to build a machine and actually to implement it in their plant in Sri Lanka. So I went to Sri Lanka and built the plant there. When I did that, actually, I always continued to look for projects like that because I liked it so much. And that's actually how the ball starts rolling, I would say.
So you got attracted to this word of building and starting up factories.
Yes, and also basically I'm very curious about everything that goes around me, curious about places in the world, but also curious about something new, something exciting that I don't know about. That's what I like.
So something which you wouldn't know about, I guess, a couple of years ago, and that's my transition to lithium, might have been this word of electric vehicles. So what got you into this topic?
Well, like I say, I was interested in a lot of things. I started with computer technology and then the internet came in the late 90s. Then basically at around 2010, electric vehicles came with the rise of Tesla. And quite frankly, it interested me a lot. So I started learning about it, reading about it. And in 2020, as we all know, the world changed a bit. And I certainly had a lot of time on my hands. What I did was I started deep diving, like you say, deep diving in the world of lithium and the electric vehicle supply chain, actually. And I still do that at the moment. So that's how I started.
Well, you're making me the smoothest of all transitions towards the deep dive, because what caught my attention first in whatever you're sharing, and you're sharing a lot of lithium-related content on your LinkedIn feed, is you were sharing a map of Europe with few points and saying, basically, it's great to have a plan to develop gigafactories. It's great to have a plan towards electric vehicles, but it sounds like we're missing a link in the chain, which is the lithium refineries. So what's the problem there, and what is the biggest challenge Europe would have to overcome with regards to those refineries?
In my view, the biggest challenge now to overcome is basically the EV supply chain in Europe, but also in the States, is really in the baby shoes. I mean, there is not much. As you stated, it all happens in Asia and China for the moment, but that's changing rapidly. They started with the push to electric vehicles, but you don't have electric vehicles without batteries. You don't have lithium batteries without lithium. You don't have lithium without mining. So you need to start up that whole supply chain. Basically what you have now, the biggest challenge in Europe and also in the US is getting started. It's a capex heavy industry. So there's a lot of money that needs to be invested in an industry that not much people understand. So you have a little bit of Wild West. You have the big names like Volkswagen, all known, they have a really good experience, but you have also a lot of gold diggers in the field that say, okay, let's start up a battery factory. It can't be that difficult, right? And we see where it goes. Well, Sometimes it goes good, sometimes it goes bad. So that's a little bit the issue we have right now.
So what happens when it goes bad? I've seen you covering quite extensively the Britishvolt story, so I guess that's an example of it going bad.
Yes, Britishvolt is going bad. I knew that from the beginning. I was interested in Britishvolt from the beginning, 2019. They don't have a product. They don't have a supply chain set up. So they don't know where the raw materials need to come from. They don't have customers. They don't have money. And quite frankly, they don't have the expertise of building a plant like that and running it. But they want money. So me as an investor, okay, what can go wrong? A lot, I think. It was from the beginning. It was a no-brainer for me. I tried to explain that, but eventually chose another way. And they said, no, we're going to do it by ourselves. Well, with the results we have right now.
So that's this battery word, which is usually the one which gets the light. I mean, you hear about the gigafactories, you hear about those projects, and Europe has been quite bragging about how fast it's developing its battery production. The next link in the chain, the one I was mentioning in the beginning, so this refining, maybe also the lithium extraction, is something which is fully lost to the specialist. I mean, if you're a specialist, you know about it. If you're a layman, that is a foreign word. So is it a topic where people should be diving in, and do decision makers dive in sufficiently? Or do they just take it for granted when it's not?
For the last years, I think it was taken for granted. It said, okay, it will happen. But quite frankly, the OEMs, the car manufacturers, let's say, they see it's not happening because the money isn't there. That's a little bit the issue. And what you're seeing right now is it's obvious that the mining industry, let's start first with where the margin is made. The closer you get to a customer, the bigger the margins is of your product you make. So it makes sense for a mining company that actually produces spodumene, which lithium is derived from, to go into lithium refining. You see that. You also see that with companies like Livent, Albemarle, SQM, the big players in the mining industry. What you will not see is actually the car manufacturers going back in the chain and developing batteries, the battery manufacturer developing lithium refineries and going back. Because quite frankly, if they have 100 million to invest, it's better to invest in something that is closer to the end customer than farther away from the customer. Now I hear you thinking, all right, that's not correct because Volkswagen has actually invested heavily in Northvolt, for instance. Northvolt is a gigafactory operator. And Northvolt is investing heavily in Aurora, which starts up lithium refinery in Portugal. So what is happening over there? Well, they don't want to invest, but they have to, because a car manufacturing without the batteries, you have a nice car plant, but basically you have no raw materials to build cars. So that's a little bit what they say, hang on, we need to do something and we need to help build up that supply chain in order for us to be able to make electric vehicles. And that's what you see with Volkswagen investing in Northvolt investing in Aurora, and so on.
There's a lot to unpack in what you just said. It makes me think of, I think 50 or 60 years ago, Ford was investing in rubber plantations because they found out that they couldn't build the tires they needed, so they had to go upstream. And the example of Volkswagen is interesting. One might say it's the great direction. What you might also say it's a bit late to move into that, because everybody talks about the lithium supply chain issue, which is going to last over the next decade. So at some point there won't be lithium for everybody. But Volkswagen's made the move. What about the Tesla of this world, which maybe didn't go upstream yet?
That's an interesting question. And it's hard to look in the mind of a guy like Elon Musk, because he's a special guy. I mean, he does things that no other more, let's say, traditional entrepreneur does. So I don't know what will happen, but basically I think he will be very hesitant to move into the market of mining, because quite frankly, if you look into the supply chain and you start from the first step, mining, it's a bulk material handling. Lithium refining is also pretty much bulk material handling, so they're very common. Although lithium refining is more specialty chemicals, part of the industry, but it's also bulk materials. Now, if you go a step further into battery manufacturing, the first step of battery manufacturing, where you actually make the electrodes, you mix up materials And that's also bulk material handling. The second step of battery manufacturing, when you have the anodes and the cathodes, and basically you roll them up and you start packing them, it's more pick and place. It's more like a car manufacturing assembly line. And then the car manufacturer is also assembly line, of course. So you have a pretty obvious, for me, divide somewhere in the battery. So basically what you're seeing is mining will go into lithium refining, but not so much in battery manufacturing, while car manufacturing might go into battery manufacturing, but not further down to lithium refining, because it's a different ball game. And I think Tesla, Mr. Musk also acknowledged that it's something completely weird for him. That's what I think. On the other hand of the spectrum, after the car manufacturing, you have also the recycling, because that's something we tend to forget. But also here we have the same. You have the dismantling of the pack. That's automation. That's pick and place, pretty much close to what the car manufacturing does. And then you grind the modules up into a black mass. Whenever you have the black mass, then it becomes back bulk material handling. And that's the circular supply chain we speak about.
So there are two types of know-how. There's the assembly and disassembly know-how, which would start middle of the battery chain up to the car and then dismantle the battery again. And
Yes.
You have this chemical play, which is from mining up to refining, up to the electrolyte and the first step of battery. If I look at the numbers today, the biggest lithium supplier in the world is Australia. I mean, they are mining the spodumene, and then only 5% of the spodumene in the world is refined in Australia. So the big chunk goes in ships and goes to China to get refined. I've looked, that's the beauty of having publicly traded company. I've looked up the quarterly reports of Albemarle, Pilbara, and all these big players. And over the past year, they've basically been printing money. They have incredible EBITDA. Is it the right time for them to go that step up in the value chain and to say, we have money on our hands so we can finance the capex, let's go into refining?
Well, I think there's no better time than today. Actually, the better time was yesterday. For them, quite frankly, you say Albemarle, SQM, Ganfeng and Tianqi, that's the other two big ones. Basically, they have cash. Everybody know that. And they are pretty much the only ones that have cash enough to take up an undertaking like that with free on-hand cash. So they don't need to borrow a lot. They have two options, in my view, that basically open up another mine and mine more lithium, or, like I said, go up into the supply chain and add some value to the product they're having right now. What you need to understand here is basically to open a lithium mine, it costs a lot of money, same like a refinery, but it takes a lot of years, because the biggest problem they will have is actually to get the permitting done. To permit the mine, a new mine, it takes at least 7 years, more in the 15 years or something like that, to start up an open mine. So when you see that with the progress is going right now into the EV, you see that basically 15 years, that's a long time from now. And quite frankly, now is the time to go ahead in the EV, in the electric vehicle supply chain. So when you have cash right now, it's quicker to go in the lithium refining. And that's what you're seeing already. There is a lithium refinery being built. Albemarle is going that way. That's what you see.
You mentioned these timelines, but still hard rock mining is the section which moves the faster from the various ways to extract lithium. So when I started this deep dive into lithium, I was expecting mining to be almost something, like the way we were doing in the 90s, but outdated. And I was expecting that evaporation ponds and direct lithium extraction would be the real deal. And the more I look into it, the more it sounds I was absolutely wrong with that statement. It sounds like mining, despite being slow, is still fast enough to be the right horse to bet on. Whereas evaporation ponds, there's still not one single gram of lithium produced in Bolivia. It just shows that it is not that straightforward to extract lithium from brine. So how can you explain this dichotomy?
Well, basically, mining will be with us forever. If you need minerals from the ground, you need minerals from the ground. How do you get them out? For lithium, I would say evaporation ponds, that's basically the cheapest method to get lithium, but it takes a long time. I do not know if it makes economical sense, because what you do is you pump up water from deep into the ground, you let it sit there for 2 years, 18 months, 2 years, and then you scoop it up and you have lithium, you refine it a bit, you change it a bit to lithium chloride, and then it goes up to the supply chain. I think mining is basically here to stay, to make it short. That's my view.
You mentioned how having the cash, the companies will go into this refining, and you mentioned how it is close enough for them to feel confident, but still there's a difference between having big trucks and digging up the soil and running a chemical plant and refining lithium. So is it really that straightforward? Is there like a booklet which says how to build a spodumene refinery, or do you still need some technical deep know-how adapted to every kind of soil or input?
Well, the process of refining lithium in lithium hydroxide and lithium carbonate is a well-known process. They do it for 50 or 60 years, not supplying the battery then, but basically lithium is also used in ceramics, in glass, in other industries. So it's a well-known process. The trick is basically, you know the process, but for batteries, you need to have lithium a hydroxide with a purity of 99.95%. Not 99.5, but 99.95%. That's a high purity. And basically, as we all know, what comes out is a function of what goes in. So if you need a high purity output, then you need to have a stable input. And that's where the trick is. I mean, the difficulty is not in producing lithium hydroxide, but the difficulty is producing lithium hydroxide with that kind of purity all the time. I mean, it's a continuous process. So you have spodumene, but basically spodumene from one mine is different from spodumene from another mine. If you get your spodumene or your raw materials from a trader, who knows, the trader might mix different minings. So you will see that in your process, and you will see that in the purity and also in the purity of the end product. And that's where it's tricky. And that's the difference between mining and refining. Refining is very much process control. You need to be on top of your process. And if something changes a bit, I say humidity or the temperature changes a bit, you need to be able to adapt the process just a little bit to get that high purity.
Talking of that process, I've seen you decomposing that process into the various steps. Can we just take them step by step for the layman, so for me, so that we really get what we're discussing here?
Sure. I mean, the first step is basically the calcination step. What you're doing then is you get spodumene as a raw material, right? Spodumene concentrate, SC6. It's called SC6. It's basically the 6% is 6% lithium and 94% pretty much useless. I wouldn't say completely useless. You still can sell it, but 94% rock. Now, the spodumene that comes in is called alpha spodumene, and that needs to be transferred into beta spodumene. The reason for that is when you do calcination at high temperature, 800 to 1050 degrees, what you're doing is basically the volume increases of the spodumene alpha. And the spodumene alpha transforms into spodumene beta. And that goes with a 30% volume increase. So the lithium that is hiding in all the crevasses, in all the little holes, let's say, in the spodumene, the whole spodumene becomes bigger in volume, 30%, but also the holes become bigger. So it's much easier to get the lithium out of the hole and you get more lithium out. That's why they do it. And that's actually the first step. If you need to visualize the first step is actually a big blowtorch blowing natural gas. You burn natural gas into a kiln and you heat up the spot. That's what it is, basically. That goes a little bit more onto that, but for layman's, that's what it is.
Absolutely clear. So that's step one.
The second step, what you do is now you have the lithium, you're gonna roast it at temperatures at 250 degrees. You're gonna roast the lithium, acid roasting is called, and with acid roasting, you're gonna get the lithium out of in a solution, let's say, and you extract the lithium. Now, what you do is with acid roasting, you extract the lithium, you dissolve the lithium, but also you dissolve the other minerals like magnesium, calcium, impurities, I call them. And that's basically the third step is actually all of that, removing the impurities. You do that by water leaching, oxidation, ion exchange. There are various steps in that. But basically, the main thing is you get the impurities out. So you have lithium by the end. Now, the fourth step is basically the lithium is not in a solid form, so you need to get the water out. So you're going to dehydrate it. You need to crystallize it, so make solids out of it. And the crystallization, because you have such a high purity, 99.95%, you need to crystallize it twice. And after that, you have lithium hydroxide monohydrate.
I was reading Henry Sanderson. I just wrote his book, Volt Rush. And in his book, he mentions how to get 1 ton of lithium, you need 2 tons of coal. Here it might be gas, or it might be... It sounds like a fossil fuel intensive process. Is that a concern?
Well, basically to process 1 ton of spodumene, you need 1.5 gigajoule of natural gas, 1 gigajoule of electricity, 24 tons of water, and half a ton of sulfuric acid and sodium ash. So it's quite energy intensive. Yes, that's a concern. A lithium refinery, in addition to that process, the process generates a lot of in-process dust and has the potential of concentrating heavy metals in byproducts and waste. So environmental issues, yeah, you have it, and you need to be concerned about that. That's also a concern for the refineries, by the way. In general, a special chemicals facility has not only the bottom line to think about, but also their reputation. But basically that means the recuperation of materials, heat, water, chemicals, solid waste disposal, instead of a liquid waste disposal, it is a must economically, but also environmentally.
You mentioned these byproducts, these heavy metals and waste. How is it treated?
Well, basically what they do is they make solid waste. Well, I hope they do it. I mean, 18 refineries in Europe I talk about. At this point, there's only one that will start operation by the end of this year. And the 17 other ones, it's still in planning phase. So I don't know what they're going to do. But if they're smart, they take a good look at heat recuperation. They take a good look at water recuperation, and they take a really good look at waste disposal, and they try to avoid liquid waste, but go into solid wastes.
The reason why I'm asking is that when I was discussing with several of the experts I got to speak for that deep dive, many mentioned me the importance of ESG and the importance of looking at the impact of the process. And I've seen that you shared an article about a way to trace the origin of lithium by looking at really the chemical characteristics. And if now I try really to be mean and to be the devil's advocate, in a market where demand is far above supply, I fear that ESG will become an afterthought, and whatever lithium you can get, you just get it.
I share your concern there. But basically what I think is now that they get whatever lithium I get is fine enough. Yes, at this point. But it won't stay that way. What you will see is the supply of lithium will catch up. The demand of lithium will go down because new chemistries will become available. I'm sure about that. And at a certain point, there will be an equilibrium or even an oversupply. And then they will start to looking at that, I believe, I hope. But yeah, for now, it is a concern. I mean, they speak also a lot about the cobalt. As you well know, cobalt is coming from the Congo, where, yeah, there are concerns, environmental concerns, but also social concerns. And still, they get the cobalt from the Congo. They don't change that. There's a reason for it. If the cobalt is in the Congo, the cobalt is in the Congo. I mean, what can you do? You have a valid concern there, but quite frankly, the thing we're having right now, I know the European Union is working on a battery passport, which tracks all the raw materials and basically the life cycle from lithium mine all the way to recycling. I think that's a really step in the right direction.
I'm just coming back to something you said before, which I took a note, and I'd like to be sure I got it right. To produce 1 ton of lithium, you need half a ton of sulfuric acid. Did I get that one right?
To process 1 ton of spodumene, so it's even less. You get less lithium for a half ton of sulfuric acid and sodium ash. But yeah, you have it right.
Because gigajoule, I get it. You get connected to the grid, or you get connected to a pipe and you get it delivered. But to my knowledge, there's no network of sulfuric acid. So does that mean it's produced on site, or how is it done?
I bet they buy it. I mean, how is it done now in the chemical industry? The chemicals you can't produce on site. Basically, you buy it and then you go from there.
Okay, so you have a gigantic supply of
Oh, yeah.
acid, which is
Sometimes that's overlooked. The logistics are huge. A refinery, a typical refinery will produce 24,000 tons of lithium hydroxide a year. That's basically one train. The logistics to get all the products in and out, I mean, they are huge. They are, I would say, tens of thousands of trucks if you do it with trucks, tens of thousands of trucks. So you need to have a location close to a port so you can ship the spodumene or whatever you want to use in by ship. The best thing you need to have is basically a train to ship in the chemicals and so on as well. But yeah, it's a gigantic undertaking. Don't underestimate it.
that's a very good dot you helping me connecting here, because I was wondering when I was reviewing this quarterly report from Albemarle, I think, or it was maybe SQM, one of the two. And one of the fields they were looking into is doing road trains. Like it looks like a train, but it's on the road. And I was wondering, why is a mining company looking into transportation? Now it makes much more sense. And the other thing is, I've been looking into 59 projects which are in the pipeline of production at some point of lithium in the next 10 years. And I was surprised to see how they put on the same level the richness in spodumene or the richness of their brine and the fact that they are close to a road or close to a highway or to, this kind of transportation facility. But now it makes a ton of sense.
If they want to build a refinery in, let's say, Munich or in a place where I live, a small place, and suddenly you have 20,000 trucks a year coming past through a local road. Well, that's environmentally is not the friendliest, but also socially you will have a lot of resistance from the local population, which is understandable. So that's why you see refineries popping up close to the shore, close to railroads. If I see plans to build a refinery in the middle of nowhere, I'm suspicious about what they're going to do there. It doesn't make sense.
Now, I feel a bit like playing Risk. I don't know if you know that game where you're just putting things on the map. And there's a geopolitical aspect to it, which I'd like to discuss later. But just before we go into that, I'm thinking if I can put my refineries wherever I want, it seems to make more sense to make them directly on the mine, because that means I'm shipping something which is much more compact instead of shipping SC6, which is more concentrated than direct supply of ore, but which is still very bulky.
Well, you have a point, and that's basically a decision. It's also the geopolitical side. Don't forget that. If you have your country running on 50 years ago, let's say, your country is running on oil. If you don't have oil, you're right, you can get into a crisis like in 1976, I believe, where Saudi Arabia said, well, we can deliver no more oil. So with the batteries, it will be the same. It's not for nothing that the European Union has labeled several minerals of the battery supply chain as strategic materials. So there is certainly a geopolitical side on it. On the other hand, if you have a refinery, you can build it close to the mine, but you can also build it close to the battery manufacturing. Now, you need to know that lithium hydroxide lithium is really reactive to water. Lithium hydroxide has a shelf life. I don't know if you know about that, but basically after 6 to 8 months, it diminishes a lot in quality. You don't want that for a battery, because if you diminish the raw materials in quality, the battery, the energy density and all those, and then the cycle things will also diminish. You don't want that. So you want to have a fresh product, if you like. Lithium hydroxide, if you make it in, let's say, Australia, put it on a ship, and ship it all the way to Europe, it's 6 weeks on the sea. Well, as you know, the sea is very wet. That's not good for lithium hydroxide. Lithium hydroxide reacts really well, let's say, with water, even the water in the air. It reacts to that. So shipping it 6 weeks over the sea, it will have an impact on the quality. That's basically a plus to build a refinery close to the battery factories in Europe. On the other hand, you're absolutely right. If you ship spodumene concentrate across the ocean, you ship 6% what you want and 94% what you don't want. Now, there is an intermediate, and that's basically a company in the UK does that. I won't tell the company, but basically what they're gonna do is, close to the mine, they're gonna build a factory that produces lithium sulfate And the lithium sulfate is then transported to Europe. You still have a waste, but the waste is much less than all the ore.
It's interesting because you really have all these shades of gray, because you have the ones which are doing direct supply of ore, especially these new African projects which are in development and some projects in Northern Australia. You have the shipment of SC6, you have the lithium sulfate, you have refining on-site and sending abroad. So it's fascinating. I'd never heard of this shelf life of lithium hydroxide. So thanks a lot for that one. You really bring an interesting new link in that chain. You opened the box of geopolitics, and that sounds like something which goes beyond what we've seen so far, which is economy, ESG, practical concerns with the shelf life of hydroxide. It's a bit about what happened if the main supplier of lithium hydroxide all of a sudden is not my friend anymore. Seeing those concerns in many countries, my question here is, what is the right scale when it comes to geopolitics? Is it like Europe, Americas, China? Or is it even more specific that maybe Canada has to take its safeties as compared to the US?
That's a difficult question for me to ask, as I'm not a politician. But I would say that the scale, NATO countries, for instance, I mean, on that scale, I believe there are two aspects on this. First, the geopolitical thing, but it's also an aspect of the countries like Bolivia, Mexico, where I am, Argentina, Chile. They want to have as much value out of that as possible. So what they're trying to do is basically they want to build the lithium refineries close to the mine, preferably also build the cars here, build the cars in Argentina, and then ship the cars all over the world, which obviously is not the right thing to do in my view. But that's a little concern because, quite frankly, what they don't want to do is they don't want to create another colonial age like in the 1700s, where all the countries in Africa basically were mined empty and the raw materials were shipped to the developed countries, so let's say Europe, to be processed into more valuable stuff. They want to do as much as possible inland. You see that what Zimbabwe is doing right now in Zambia.
To that extent, I'm curious to get your view on, you mentioned Mexico, which to me is a good example, because the biggest development project in Mexico is 50% owned by Ganfeng, maybe even more than 50%, I'm not sure, which means it is a Chinese asset in Mexico. So if you enter in a trade war for whatever reason between the US and China, would they accept lithium coming from Mexico if it is a Chinese lithium?
I don't know. What I do know is Ganfeng, who is starting up the Sonora mine here in Mexico, they will ship all their ore to China. I mean, China for now is, I believe, 68% of the products from the lithium refineries come from China, but they only have 21% of the lithium in-house. So it needs to come from somewhere. And that somewhere is mines like Ganfeng, like the Sonora mine in Mexico. I'm sure, well, actually, I'm pretty sure that the Mexican government doesn't want that, but basically it's a little bit of fait accompli. The mine is in Chinese hands, and to nationalize it, that's something the Mexican government can't do and will not do. However, the new mines that's coming up in Mexico, that potentially will come up in Mexico, will be owned by the people. That's basically now, I think for the last 6 months or so, written in law. So they can't be owned by foreign companies anymore. It's basically will be processed by a Mexican state company.
So even at that level, you might say Mexico is part of the really muggle here. So I might say something stupider than me, but the ALENA, I mean, Mexico, US, Canada. So you would think if US and Canada are beefing up their supply chains, maybe Mexico doesn't need to. But it seems like every country wants to have some security about access to lithium in the future and access to EV revolution.
They call it the gold rush, the current day gold rush. If there's lithium in the ground, you want to get it out and you want to make value of it for the profit of the people, at least in Mexico, which sounds a good idea. However, the lithium, the mines that are not yet operational but can go online, basically they are lithium, sedimentary lithium, they call it. So basically lithium hiding in clay. And to extract lithium from clay, that's something that is not yet done on industrial scale. So quite frankly, they're a long way off. In addition, if you don't want foreign investment or foreign involvement, it's not so easy to get the required funds to start up a lithium supply chain. You don't have also the expertise in-house to build up that supply chain. You mentioned in the beginning of this podcast, you mentioned Bolivia. That's a key example. For 20 years, they want to do it on their own. Quite frankly, for now, what do they have to show for? Well, pretty much nothing, I believe.
To me, really, as a layman, Bolivia is an incredible thing. I can't wrap my head around it. You have 58% of the world's lithium resources, and you don't produce a single gram.
Yeah.
And you have this multi-phased tender for whom is going to be the technical partner, and still they haven't reached a point where they've taken a decision. So I have my difficulty with it to really understand it. And the other thing is what you mentioned about the know-how is pretty impressive. I was looking, at names of companies, and the companies were called European Lithium, European Metals, and all these companies are from Australia. And then you had Argentina Lithium, Lithium Americas, Nevada Lithium, American Lithium, and all these companies are from Canada. So it sounded to me like they are, in fact, out of these about 60 projects in development, I think something like 40 of them, so 2/3, are done by Canadian and Australian companies alone.
Yep.
So to me, what that tells is that there is a knowledge and a know-how in certain countries because of their mining background, because of their oil and gas background. And when you come to touchy and kind of unknown fields like lithium, it's still in development, well, you rely on that experience and they have an edge.
Absolutely. What you see in Bolivia wants to absolutely avoid what would happen in stripping out the gold and the valuable metals and materials in the 1700s. They want to avoid a same scenario. So they're really reluctant to invite the foreign experts in to get the lithium out. And that's basically what is happening. They say, yeah, but of course the foreign investment, if you do a foreign investment, you want to have a return from it. And that return wants to be as much as possible, but Bolivia wants to have as much as possible kept in Bolivia to improve the life of the Bolivians. So it's a little bit, haggling, I would say, but it took them 20 years now and they're still haggling, which is not a good thing. Not for the industry, not for nobody, actually.
You mentioned the investment, and that is also something which I found clever in what you were sharing, which is it is capital intensive, so you have to raise money.
Yeah.
And you have to raise money up front long before you actually deliver something, which means for a while you're delivering on a PowerPoint and you might or might not reach what was written on your PowerPoint, which leads to sometimes inflated expectations, sometimes a shortcut in the timeline, which are not that realistic. So all these projections we see of what's happening towards 2030, how much is real and how much is wishful thinking?
Well, I think it's anybody's guess, really. But you're absolutely right. The PowerPoint presentations, and I say that to everybody who wants to listen to me, the PowerPoint presentations are written to entice investors to invest. So what I want to say is, we're going to have that, we're going to have that, we're going to have that. 2 years later, it's very nice. But in reality, I don't know. It wouldn't surprise me of the gigafactories. If we talk about gigafactories right now, 50% of the gigafactories, the capacity won't be there. Pretty sure of it. There will be more firms like British Volt that will go the same way. I'm certain of it. As an investor, basically, if you want to step on the investing in the green wave right now, I would say do it. It's still good, but do your homework. If you see a firm like, let's say, Tony Volt, my name then, building a gigafactory, check out who that Tony guy is. Does he have a nice, shiny website and that's about it? Check him out before you invest. Do that. What you're seeing right now is basically many people are thinking, they want to step on the train. They want to be there before it's too late. They don't want to say, for Amazon, I didn't invest in Amazon, I didn't invest in Google, and I missed out on that. Well, I would say do your homework, and it's better to skip on a good investment than to enter a bad one.
There's a last leg in that journey where I'd like to catch your brain, which is when I started this full investigation, I'm a water professional, so I'm starting from water. That's my thing. That's the thing I understand. And the reason why I got attracted to this deep dive into lithium at first is that the promise of direct lithium extraction sounds so cool. And
Yes.
I mean, it's perfect. You are taking whatever groundwater which has a certain level of lithium, and actually just in my backyard, actually, there is this type of water which is rich in lithium. You bring it through steps which the water industry would consider pretty standard. I mean, we have the technologies, they have been tested. Maybe they need to get slightly adapted. And at the outlet, you get lithium. Sounds really so cool. I'm digging into the topic. The more I'm hearing, that might as well never happen. So what's your vision on direct lithium extraction, and where will it play a role if it ever plays a role?
Well, basically, I share your enthusiasm for the process. I strongly believe in DLE. I have high expectations about that. But it sounds too good to be true. I mean, you pump up a hot soup, let's say, you take out what you want, and you pump it back in the ground. Wow, oversimplified, of course. But we are not there yet, and that's also what you hear about. We are not there yet, whatever the companies involved claim. It still has technical issues that need to be resolved before mass production. I know about one thing, the real impact on diluting the underground brine deposit is still unknown. You don't know that. Also, what you have is, if you have a DLE plant, it's a hot soup. Basically, it's very abrasive for the piping. It's very abrasive for all the materials you use. There are 3 or 4 different techniques to get the lithium out. But if you use membranes, the membranes tend to clog up a lot. If you have an industrial process and 50% of the time the plant is down, eventually that's an issue. But I agree with you, Vulcan Resources in your area, I believe, and Control Thermal Resources in California, the Salton Sea in California. I believe that are the two that do it. Also, Livent has something operational, but it's still not on an industrial scale. So I do believe in the process, and I really hope it gets off the ground, but we're not there yet.
And will it go out of the ground first as a standalone, or is it a clever complementary technology to evaporation ponds?
Good question. I know Livent does it in their, I believe in Chile it is, while Thermal Resources in California is actually an extension of a Berkshire Hathaway plant that uses the heat to produce electricity. Because quite frankly, if you have a hot brine, you can also make steam and electricity. And that's basically a known process which is done already. The only step further, you need to take the lithium out. I think, in my view, I don't know the process that much, but I do believe it's a standalone process in conjunction with the electricity production, like Vulcan in the German plant. I would say if it can be done in Chile, Bolivia, Argentina, wow, you get rid of the evaporation ponds, which is environmental not so friendly, but I don't know which way to go actually.
To close that deep dive, you made clear how there is a separation between the chemical part and the assembly part, and how that calls for 2 ends, the one which goes up to batteries and cars, and the other which goes chemicals and mining or evaporation ponds, whatever it is. Yet, when you look at PowerPoints, there are players which are looking at building the vertical. And if you look at what Ganfeng is doing, somehow they are building that vertical. So if we look now in a crystal ball in 5 or 10 years in the future, will we see these powerhouses going from the mine somewhere in the world up to the battery in the car and maybe up to the car?
To predict the future, you need to look at the past. And if I look at the past, I mean, you had the same thing going on with microprocessors, this chipping technology. There was also some people who went first pretty much completely vertical, and some didn't. Now you have a design part with companies like Synopsys. You have a part where they produce it, the fabs, let's say, like TSMC. Then you have a third part, the packaging that actually make the chips. And then you have delivery, machine manufacturing like ASML. Basically, the factory that went all vertical had to stop because the research and development part, to be at the top, the research and development was way too much to do it. And that's why you see that separation. And I think with batteries, it will be the same.
So we're rather heading towards ultra specialization than we're heading towards verticals.
I think so. Because quite frankly, it's a capex intensive industry. And if you can go back to British Volt need to invest in research and development, need to build a pilot plant to do their testing, need to build a gigafactory. They all need to do that. Quite frankly, you need to have a lot of money to do that, because what you do is you're making 3 companies at once. So basically, what I would see is you have one factory that does R&D, you have another factory or company that basically makes a pilot line, and the designers can test their product on that pilot line at a fee, of course. And then basically you have the gigafactories who make the batteries on an industrial scale with technology that actually comes from somewhere else. And that's what actually will happen with the new guy that's taking over British Volt, Recharge Industries. They have their own products, but basically the technology they use is not their own. They use technology from C4V, that's basically another company. So what they are going to do is basically they're gonna produce on an industrial scale batteries. And that's what British Volt also had to do. But they choose to also build a pilot line, to also build a research and development center. And that can also work. Look at Northvolt. Northvolt does it like that. But Northvolt has a strong backing. I mean, they have $1 billion as a backer, while British Volt has nothing as backing. So you can't do that.
You have the risk of spreading yourself too thin.
Yeah, absolutely.
Tony, it's been incredible to tap into your brain for that deep dive. So thanks a lot. And to round off these interviews, I have a series of rapid fire questions. I'm sorry because they might be a bit water oriented at some point, but I'm sure you also have a joker card which you can use whenever you want.
It's time for the rapid fire questions.
The principle is I try to keep the questions short and you have to try to keep the answers short, and I'm the one sidetracking, so don't worry. My first question is, what is the most exciting project you've been working on and why?
Well, one of my first, let's say, designing, building and installing a temperature supervisory control system for a line with hundreds of curing ovens for tires in Sri Lanka. Why? Because early 90s in rural Sri Lanka, most line operators had never seen a TV before, let alone I needed to instruct them how to operate the laptop computer. So that's something that was exciting.
Can you name one thing that you've learned the hard way?
Well, even the best programs fail if you cannot achieve the support of all the stakeholders. Stakeholder management is really important.
Is there something you are doing today in your job that you will not be doing in 10 years?
I see myself, well, in 10 years, I'm not 20 anymore, so in 10 years it's already a long part. But basically the hands-on part, I see that already. The hands-on part of actually building and visiting sites, conducting the plant, is becoming less every day. The advisory part is growing. So basically advising plants, advising people who want to start manufacturing plants. That is growing.
I'll slightly change the next one. What is the trend to watch out for in the industrial sector?
For batteries, I would say battery chemistries are evolving. And quite frankly, I see them evolving into solid state batteries. And hopefully in 10, 15, 20 years into battery on chip technology. That's something that interests me.
I've seen you posting about the various possible materials that could replace lithium. You're absolutely not liable to your bet at all. But if you had to bet on just one, which one could it be?
I would say nickel, cobalt, manganese will go further. Now we are at 811. It will go further to 955. So higher nickel content. Basically the existing technology. That's my bet. Just for a short while, I think from the next decade onwards, it will be solid state.
Well, Tony, it's been a pleasure to spend that hour with you. If people want to follow up with you, what is the best place for them to look you up?
Well, the same way you look me up, and basically I post every Monday, I post something new about the EV supply chain, and more and specifically lithium and the chemistries and all those kind of things, link it.
So LinkedIn is the place to follow you, contact you?
Yes.
Awesome. Well, thanks a lot. And I might be interested in a follow-up at some point to see how all of that develops in, let's say, 1 or 2 years. So Thanks a lot for your time, and I hope to speak to you soon.
You're welcome. It was my pleasure. Thank you for having me.
Thanks for listening to Don't Waste Water. This podcast was brought to you by GF Piping Systems. Loved this episode? Head over to Apple Podcasts to subscribe, rate, and leave a review. See you next time.